In this video, we are going to see heuristic search and what are the different algorithms you can use for heuristic search. So let's see. A heuristic search is a technique to solve the problem faster than the classic methods, or you can use this technique to find out an approximate solution when the classic method cannot. This is a kind of a shortcut as we often trade one of the optimally completeness, accuracy, or the precision for the speed. A heuristic, or simply you can say that heuristic function takes look at a different search algorithm, and at each branching step it evaluates the available information and makes a decision on which branch it has to follow. So it does so by ranking different alternatives. This heuristic is any device that is often effective, but it will not guarantee that it will work in every case. So why we do need this heuristic? The one reason is to produce in a reasonable amount of a time a solution that is good enough for the problem in the question. So it does not have to be the best. An approximate solution will do since this is fast enough. So most of the problems are exponential, and this heuristic search let us reduce this to a rather polynomial number. So we use this heuristic search in artificial intelligence because we can put it to use in a situation where we can't find known algorithms. In heuristic search, there are two basic heuristic search techniques. The one is a direct search and another one is a weak heuristic search. So when we talk about this direct heuristic search, this direct heuristic search is also known as a blind search or uninformed search, or it is also known as a blind control strategy. These aren't always possible since they demand much time as well as a more memory. So they search the entire state space for the solution and use an arbitrary ordering of the operations. So here you can see these two examples of direct heuristic search. The one is a breadth first search, which is commonly known as a BFS, and the another one is a depth first search, which is known as a DFS. The another kind of a search technique is a weak heuristic search technique. This weak heuristic search technique is also known as a informed search or simply the heuristic search, or it is also known as a heuristic control strategy. So these are effective if applied correctly to the right types of a task, and it usually demands a domain specific information. We need this extra information to compute the preference among the child nodes, to explore and to expand. So each node has a heuristic function associated with it, and here are some examples of the weak heuristic search. That is best first search, then A star search, bidirectional search, taboo search, beam search, simulated annealing, hill climbing, constraint satisfaction problem. So these are the common weak heuristic search techniques that we are using in artificial intelligence. Now let's talk about the heuristic function. So this heuristic function is a function which is used in a informed search, and it finds the most promising path. It takes the current state of the agent as its input, and it produces the estimation of how close agent is from the goal. So there are multiple nodes are involved, and you are trying to find out the shortest path between this node. The heuristic method, however, might not always give the best solution, but it guaranteed to find a good solution in a reasonable time. So heuristic function estimates how close a state is to the goal, and it is generally represented as h of n, and it calculates the cost of optimal path between the pair of the states. And the important thing is that the value of heuristic function, it is always positive. This function is, you can write this function as h of n, or the condition it must be satisfied is h of n is less than equal to h into n. Okay, so here this h of n is a heuristic cost, and h into n is a estimated cost. So as given here, we can say that the heuristic cost should be less than or equal to the estimated cost. Now, before starting to the algorithm, first see what is a pure heuristic search. So, pure heuristic search is a simplest form of the heuristic search algorithm. It expands the node based on their heuristic value. So that heuristic value is how we can represent this heuristic value. It can be represented by h of n. So it maintains, in this kind of a search technique, we are maintaining the two lists. One is a open list and another one is a closed list. And in the closed list, we are placing the nodes which are already expanded, and in the open list we are placing the node which have not yet been expanded. There are multiple iterations are involved, and on each iteration, each node n with the lowest heuristic value is expanded, and it generates all its successor, and n is placed to the closed list. The algorithm continues and unit a goal state is found. So in this informed search, we are going to discuss the two main algorithms. The one is a based first search, or simply it is known as a greedy search, and second one is a star search. Now let's see the first algorithm, the first heuristic algorithm, that is based first search algorithm. So this based first search algorithm, it is also known as a greedy search algorithm, and this algorithm will always select the path which appears the best at that moment. This algorithm, it is combination of depth first search and the breadth first search algorithm. This based first search algorithm, it uses the heuristic function, and this allows us to take the advantages of both the algorithm. So here you can make the use of BFS as well as the DFS algorithm. With the help of based first search algorithm, at each step we can choose the most promising node, and we can expand the node which is closest to the goal node, and the closest cost is estimated by the heuristic function. So this function, you can give this function as f of n is equal to g of n. Here h of n is the estimated cost from the node n to the goal, and this greedy based first algorithm, it is implemented by priority queue. Now let's see what are the different steps we have to follow. The first step is place the starting node in the open list. So the main thing here is we are maintaining two lists. One is an open list and another one is a closed list. So first select your starting node and place that node in the open list. Then if the open list is empty, then stop and return the failure. If there is no node, then you can stop. If the list is empty, then we have to stop there, and if there are some nodes, then remove that node, or take that first node and add that node in the closed list. Okay, so remove the node n from the open list which has the lowest value of h of n. So here h of n stores the heuristic value, and place that value in a place that node in a closed list. Step 4 is expand the node n and generate the successor of n. So here we have to find out the successor of selected node. Suppose you have your starting node is S, and there are two directions from that node, from to the node A, from node S to the node A and to the node B. Then in that case, these are A and B are the successor of your node S. So each successor of a node N we have to find out and check whether that node is your goal node or not. That means that node that you are actually searching, is it that node or not? So if any successor node is a goal node, then return the success and terminate the search and proceed to the step number 6. So for each successor node, algorithm check for the evaluation function f of n and then check if the node has been in either open or the closed list. If the node not been in the both list, then add that node in an open list and return to the step 2. So here what we are actually doing, we are starting with the one node, starting node, and we are maintaining two lists, open list and the closed list. Then we are adding the one node in that closed list, in that open list, and then we are finding the successor of that node, and we are checking the successor of that node are the node that we are actually looking for. If it is not, then we are again checking the heuristic value of that node, and we are adding the node which are having the less heuristic value in the closed list. We have to do this until we reach to the last node or our destination node. So what are the advantages of this algorithm? So here this best first search can switch between BFS and DFS by gaining the advantages of both the algorithm. So here we are taking the advantages of breadth first search as well as the depth first search algorithm. And this algorithm is more efficient than the BFS and the DFS algorithm. Along with these advantages, there are some disadvantages. The one is this based first search algorithm, it can behave as an unguided depth first search in the worst case scenario. The second disadvantage is it can get stuck in the loop as a DFS. So there is a possibility, as we are using some concepts of a DFS, so it can get stuck in the loop as a DFS. And this algorithm is a not optimal algorithm. These are the disadvantages of the based first search algorithm in an artificial intelligence. Now let's look at the example. So here is one example where consider this below search problem, and we will traverse it using the greedy based first search algorithm, and at each iteration the node is expanded using the evaluation function. So here we are using f of n is equal to h of n, which is given in this table. So here you can see one tree. Along with that there is one table given. This table consists of the node and the associated heuristic value for individual node. Okay, so here is the weight. Here you can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 nodes are there, and some weight is assigned to the each edge, you can say here. So the weight assigned to the S to A, the cost required for reaching to the node A is 3. Here from S to the B is 2, B to the F is 1, B to the E is 3, E to H is 5, A to D is 1, A to C is 4, F to I is 2, and F to G is 3. Now here some heuristic values are given. For node A, value is 12, for B it is 4, for C it is 7, for D it is 3, for E it is 8, then for F it is 2, for H it is 4, for I it is 9, for S it is 13, and for G it is 0. Now we have to use this heuristic value in case of a best first search. So here we are we will first create two lists, open list and the closed list. So in this search example, suppose we have created this two list, open and a closed list. So in the first iteration, we are going to start from this first node, that is node S, and suppose from node S we are first taking that node S into the closed list, and then find the successor of this node S. So successor of this node S is node A and node B. Now as these two are the successor, add these two nodes in the open list. Okay, so initially in an open list you have two nodes, node A and node B, and in a closed list you have node S only. Now in the next iteration we have to check the heuristic value for each node. So heuristic value for node A is 12 and heuristic value for node B is 4. Now as this node A and node B both are in the open list, for that purpose only, or the node which are only in the open list, we have to compare the heuristic value. So node A heuristic value is 12 and node B heuristic value is 4. So the 4 is less than 12. So we are going to add this node B from this open list to the closed list. So now in the open list we have node A, and in the closed list we have node S along with the node B. In the next iteration, find out the successor of B, because this B has a less heuristic value. So find out the successor of B and add those nodes in a open list. So now successor of B is E and F, so add it in open list. So now your open list consists of 3 nodes, E, F and A, and the closed list consists of only 2 nodes, that is S and B. Now again compare the heuristic value of node E, F and for heuristic value of node E and F only. So here from this table you can say heuristic value of node E is 8 and heuristic value of node F is 2. So 2 is less than 8. So remove that node F from the open list and add it to the closed list. Now your open list consists of only 2 nodes, E and A, whereas your closed list consists of 3 nodes, that is S, B and F. In the next iteration, find out the successor of node F. Now this node F successors are node I and G. So add these two nodes in the open list. So now open list consists of node I, G, E and A, whereas closed list consists of 3 nodes S, B and F. Now compare the heuristic value of node I and G. So the heuristic value of node I is 9 and the heuristic value of node G is 0. So the 0 is less than 9. So remove that G node from the open list and add it to the closed list. Now this open list consists of only 3 nodes, I, E and A, whereas this closed list consists of 4 nodes, S, B, F and G. So this is the final solution. This is the final solution or the final path. So final path will be from node S to node B, from node B to node F and from node F to node G. So this is the shortest path to reach the node G from node S. So this is how this best first search algorithm will work. If you talk about the time complexity and space complexity of this algorithm, so in the worst case complexity of time complexity as well as space complexity of this algorithm is big O of b raised to m. So here m is a maximum depth of the search space. As we have seen in a part of advantages, this algorithm is not an optimal algorithm and it is a incomplete even if the given state space is finite. So this is about the best first search. Now let's see the second algorithm, that is a star algorithm. So this A star search algorithm is the most commonly known as a best first search algorithm, and it uses the heuristic function h of n, and the cost to reach the node from node n from the start stage. It has combined the features of UCS and the greedy first search algorithm. So by using this, you can solve the problem efficiently. The A star search algorithm finds the shortest path through the search space using the heuristic function. This search algorithm expands the less search tree and provides the optimal result faster. This search algorithm is similar to the UCS except that it uses g of n plus h of n instead of only g of n. So in A star algorithm, we use the search heuristic as well as the cost to reach the node. Hence, we can combine both the cost. So here we are finding f of n by adding g of n and h of n. So this sum is called as a fitness number. So here f of n is the estimated cost of the cheapest solution. G of n is the cost to reach the node n from start state, and h of n is the cost to reach from node n to the goal node. Okay, so let's say the steps for the A star search algorithm. The first step is place the starting node in an open list. See, in case of all heuristic search algorithm, we are maintaining these two lists, open and closed list. So the first step is again place your starting node in an open list. The second is check if the open list is empty or not. If the node is not present, or you can simply say if the list is empty, then return failure and stop. The third step is select the node from the open list which has the smallest value of the evaluation function, that is the combination that is the addition of g of n and h of n, and if the node n is a goal node, then return the success and stop. Otherwise, find out the successor of that node n and again calculate f of n, then find out the the lesser value of f of n from that node and add that node in a closed list. So if the node n is already in an open and a closed list, then it should be attached to the back pointer which reflects the lowest g of n value. And last step is make that list empty. So this heuristic search algorithm, A star heuristic search algorithm, is the best algorithm as compared to the other search algorithm. It is optimal as well as a complete, and this algorithm you can use for solving the complex problem. If we talk about the disadvantages, so this algorithm, it does not always produce the shortest path. The second disadvantage is it has some complexity issues. And third is the main drawback of A star algorithm is the memory requirement. So as it keeps all the generated nodes in the memory, so it is not a practical for the various large scale problem. Now let's see the example. In this example, we will traverse the given graph using the A star algorithm. The heuristic value is given in the table, and every time we are going to calculate f of n by using the formula f of n is equal to g of n plus h of n, where g of n is the cost to reach any node from your start state. And here again we will use the two lists, open and the closed list. Here is that example. The graph, here is the graph which consists of 6 nodes, and this table is given which represents your state and the heuristic value associated with each node. So for the node S, value is 5, for A it is 3, then for B it is 4, for C it is 2, for D it is 6, and for G it is 0. So in the first step, we will initialize the starting node. Suppose your starting node is a S node. So add that node in the open list. The heuristic value of this node S is 5. So the second member you have to add as your heuristic value in that list. In the first iteration, find out the successor of this S node. So now here in this diagram you can see the successor of S is node A and node G. Okay, so the S to A and S to G. Now for this path from S to A, we have to find out the f of n, as well as for the path S to G, we have to again find out the f of n value. So for S to A, f of n is the g of n. So here g of n is a weight of that age. So here the weight of that age is 1, and heuristic value of A, that will be your h of n. So the 3, the value here is 3. So add this 3 plus 1 is 4. So therefore here from S to A it is 4, and from S to G again calculate this f of n for S to G. So f of n is this 10 is your g of n, and h of n, that is heuristic value of g. Heuristic value of g is 0. So 0 plus 10 is 10. So f of n for S to G path is 10. In the next iteration, find out the f of n, the lesser f of n out of these two. So here the 4 is less than 10. So we will in the next step we will find the successor of this node A. So successor of this node A is node C and node B. Again here find out the f of n. Now you can say that in a second iteration, the one path is S to A to C, and second is S to A to B. Now from S to A to C, f of n value is this 1 plus 2, that is 3, and the heuristic value of B node. So it is 4. So 4 plus 3 is 7. So for S to A to B, f of n value is 7. And from S to A to C, the value is this 1 plus 1, 2, and the heuristic value of node C. The value of C is 2, that will be 4. In the next iteration, again compare the lesser f of n value. From this 3, for the path S to A to C, heuristic the f of n is less, that is 4. So find out the successor of node C. The successor of node C is node D and node G. Again find out the f of n for this path S to A to C to D, and second is S to A to C and G. So for path S to A to C to G is 1 plus 1 plus 4, that is 6, and heuristic value of node G, that is 0. So here the f of n for this path is 6, and the another path is S to A to C to D. It is 1 plus 1 plus 3 and the heuristic value of D. So heuristic value of D is 6, so it will be 11. So from this you can find out the minimum value f of n, minimum value f of n. So we have 4 values, 6, 11, 7 and 10. The minimum is 6. So in iteration 4, this iteration 4 will give the final result as S to A to C to G. So it provides the optimal path. This is your optimal path with the cost 6. So this is how this algorithm works. So in this case, you can say the A star algorithm, it will return the path which occurred first and it does not search for all the remaining paths. And the efficiency of this algorithm, it is depend upon the quality of heuristic. Whatever the values given in the table, it is totally depend upon those values. And A star algorithm will expand all the nodes which satisfy the condition f of n. If we talk about the time complexity and space complexity, then it is big O of b raised to d, where b is the branching factor.